All right, so welcome everyone to our CCNP ENARSI class. Thank you very much for being here. I want to start off with a quick update information about something we learned about the continuing education process. Now, one of the things that we briefly discussed last week was the fact that if you are trying to renew your certifications, you can gain CEs or continuing education credits. Now, these are not CEUs from Stanley Community College. These are CE credits that you can earn by taking classes at an instructor training center. Some of you who were taking my CCNP class last semester, the Enterprise Core or Encore, and passed successfully would earn 64 credits. Well, we had one of your classmates apply to get the credits and they were turned down. And the reason they were turned down is because you will see inside of NetAcad itself, I don't have very much inside the class. So it looks like all you're doing inside of NetAcad are the chapter quizzes and the final, and that's it. Well, we know that all of us are actually doing 25 labs, at least all the chapter exams, the course final, the skills assessment. Those of you who got through Enterprise Network or Encore know you did a lot of work, a whole lot of work. Well, what we've come up with to keep that from being an issue again is this. I have put into the ENARSI class a simple quiz that you all need to do. This quiz states, I acknowledge that I'm required to complete the following items in order to fully complete this course. Some of these are on netacad.com, while others are on resources at Stanley Community College. Upon successful completion, Stanley Community College's ITC can provide documentation of the items below. Completion of 25 labs on SCC's NetLab Plus system, netlabs.stanley.edu. Completion of all chapter exams inside of netacad.com. Completion of course feedback on netacad.com. Completion of the written final exam on netacad.com, and completion of the required skills assessment. Hands-on lab on netlabs.stanley.edu. Now, you need to do this quiz and answer yes to it. And then what will happen is when you go to turn in this credit, they will know that you did a lot more than just the simple exams inside of netacad.com. Those of you who have applied right now, okay, Philip, I actually sent an email through the support, not through the support system, but through the people over support with your name in it, telling them that you had successfully completed my class and that you had done the amount of work that I showed for the other student. So if any of you are in my Encore or were in my Encore class and are planning to submit your hours for CE, first off, it has to be done soon, because you'll notice one of the rules is it must be done but by 90 days within course completion. So if you finish, you need to get that in. We're about a month past the end of the class at this point. So be aware of that. You've got to get that done. Number two, let me know and I will forward to support your name to make sure they know that you did successfully complete. I actually forwarded the student who was marked was denied. I forwarded his entire NetLabs usage report showing all the hours of the labs that he did. So just be aware of that. You'll notice that ENARSI only gets you 40 credits because this class is not as hard as, it's not quite as much work in terms of content as Encore. But be aware, if you need to renew your CCNA, if your CCNA is good and you want to renew it for 3 more years, all you need to do is complete this course successfully and then use this information right here. You go to this ce.cisco.com and you put that information in. Okay. And then submit it, and then they will go and look, and they will either give you credit or not, and they should give you credit. Again, I had to apologize to that student. I was a little mad. I won't lie to you. I kind of showed my rear end. I was pretty unhappy that they had turned down. Oh God, you wouldn't believe the Encore. Yeah, it's insane. In fact, I won't show anybody's personal usage, but I will do this real quickly. Just to give you an idea of the amount of labs completed on Encore. For the entire class, We'll grab a little. Okay. That was the number of hours of labs completed. So 889.98. So we'll just say 890 hours. 890 divided by 24. 37 24-hour days worth of labs were completed. Or we could do it another way. 890 divided by 8-hour work days. 111.25, basically 111 work days, 8-hour work days worth of labs were completed by the Encore class. So yeah, y'all didn't play around. You did a lot of work. So that's one of the reasons I did get a little bit disgusted and got kind of, again, well, it was not very nice. And I had to apologize. I did apologize. But I was angry because it made me look bad, and it kind of was an affront to that student who had done so much work. All right, but please do this quiz right here in NetAcad. Go do that right now if you can, so that I have that on record. It's on record, and they can see it, and they know that you are doing more than just the chapter exams inside of here. Okay. Now, if you want to do the practice quizzes, you can do those also. But these exams are what I'm requiring as far as part of our class. Any questions before we move on?
Don't we have to log in with your token in order to even get this class populated?
No. If you had already been in my classes before, I put you in here automatically. So okay. You probably should already be in there.
Okay.
I can check to make sure. Let me pull this over here out of the way so other people can't see all the students' names in the class, but I am pretty sure that I have added you already. And if I have not, then you were added late, weren't you?
Yes.
All right, let me go add you then. You've had a class with us before, correct?
Not CCNP core, but the other classes.
You've had the others. You're enrolled. You're in the class.
Okay, so I will.
Yeah, you're in there. So if you log in to netacad.com now, you should already be in. Yeah, I'll put you in. You're in. Okay. How do you pronounce your first name, Janaka? Is it
Vijay Muni?
Vijay Muni.
Yeah.
Say one more time.
Vijay Muni.
Vijay Muni. Okay. Vijay Muni. Soza.
Yeah.
Soza. Okay.
Yes.
You're definitely in. I've got you in there. So you're in the class. Excellent. Okay. So everybody, that is, please do that required quiz for me, so we know that's done. All right. Other questions? I want to real quickly go back through just 2 seconds here. You're all working on 1 through 3. Don't forget, this is the required items for this course to pass successfully. All the chapter exams, 25 chapter labs of your choice. So you don't have to do every lab that's in the class. I don't expect you to do them all, but 25 labs of your choice. Final exam, which you do have to score 75 or higher. If you don't make a 75 first chance, you can retake it. And then the skills exam lab, which will be one of the skills assessments inside of NetLabs. So when you go into NetLabs and you schedule for yourself and you go do, you find our ENARSI class, we will do one of these 2 right here. I'm not going to tell you which one yet. That way you can't be studying. Now, I will tell you, I've seen many of you doing the labs. Thank you. I have actually been wanting to do some labs myself, and I've kind of stayed away from it because I saw some of you working on it. I saw 2 of you working today. We do have 3 CCNP pods. There's 17 students now in this class, but that's still plenty of pods for 17 students, especially we've got y'all spread around the world. So our time difference should make it pretty easy for us to do this. You also notice there are 2 different types of labs. The troubleshoot labs require you to load those configs. I know it asks you to have them checked. So what I did was, in order to make life easier on you, I added into the class the instructor lab source files. When you open these up, you will actually see it has the my downloads. It has the lab source files, and so it has the instructor versions of all the labs that we have. Now, be aware, please don't just open the lab and read the answers. Try to do the labs first without looking at the answers. If you get stuck or you say you completed ticket 1 and you want to check to see if you got it right. Well, go into the lab and open it up and check to see if you actually did complete the lab successfully. See if you got the ticket completed. All right. So that's why I put these in here for you, to make life easier on you, so you can check in case you get stuck. But if you just go and look at it and lean on that as a crutch, you're not going to pass the exam. So don't do that. Questions? Any questions at all? All right. Well, let's hit some actual content then, folks. Chapter 1 is a quick look at IP addressing and reviewing. One of the things about this is it is a review of both IPv4 and IPv6. And in fact, it does look at the difference between how DHCP works on IPv4 and how DHCP works on IPv6. It goes through. Now, I really like the fact that they actually go through this, because many of us forget this. And that is, how does a PC determine whether or not an IP address is local or remote? And what it does is it takes its IP address, in this case 10.1.1.10, adds it to the subnet mask that is configured on 10.1.1.10. And what falls through there is the actual subnet ID or network ID PC1 is on. It then takes the IP address of the device it's sending to. In this case, it's 10.1.1.20, which is PC2, adds it to its subnet mask, the subnet mask of PC1, to see if they are both on the same network. If they are, it will then look in the ARP table to see if it's got a MAC address for it, or actually look in the MAC address table, its local ARP table. If it doesn't have one, it's in an ARP request, get an ARP reply, build the frame, send it out to PC2. If these didn't match, what does it do? Okay, so what if it's sending to 192.0.2.1? What happens when it does the ANDing? What is it going to find out?
Oh, you're on mute.
Yeah, no, I'm talking to another instructor. I'm sorry. Yeah. Okay. Sorry, I was talking to another instructor. So what will happen when it ANDs it? It ANDs it. So if I was to take 192.0.2.1 and AND it to the mask for PC1, it's going to find out the PC1 and this PC on the right here are not on the same network. So what does it do? Come on, everybody.
Send it to the gateway.
Send it to the gateway. If a gateway is configured. So yes, it will send it to the default gateway if a default gateway is configured. What does it do if there's no default gateway configured on the PC? Bit bucket. Don't forget your old bit bucket. Okay. This, folks, it's funny. We're in CCNP, and we're looking at a CCNA1 topic that they're reviewing. But that's how fundamentally important knowing how this is to be able to know that. Okay. Now, DHCP, good old Aunt Dora, discover, offer, request, acknowledgement, the four steps. Remember that discover and request are client items, offer and acknowledgement are server items. The good old Dora process here is typically all broadcast. It actually depends upon the system and who built the DHCP system that's in use, as whether or not it is actually all broadcast. The discover is always all broadcast. And then the offers and acknowledgements can sometimes be sent in less than just broadcast. They can actually do it's not really directed, but it kind of is. So, but the big point here is discover is a broadcast. So if you are not sitting on the same segment as the DHCP server, your router is going to have to forward that using the DHCP relay agent. This is straight up CCNA 3 right here, the helper address. I will tell you, real world, Cisco had put in a command called IP DHCP server, because this command, can anybody remember what else it sends? It sends boot P 69 and 68, I believe it is, So it sends the 2 for DHCP. But what is the problem with this command? Anybody else remember? It doesn't just send DHCP. What else does it send?
TFTP?
Not TFTP, but other services like TCP small services.
I thought there were several.
There are several. There's like 8
No,
of
it was
them.
anything that needs broadcast facilitation.
Yep. So it's see if I can find the actual numbers here. All right. What services does IP helper addressing? Yep, there we go. Now I'm trying to find it all, but there's a whole set of them that it actually uses. So the problem with it is it doesn't send just DHCP. That's why they did create a command called IP DHCP server, but almost nobody uses it. One of the ones that it sends, I think, is I think it's not CDP, but there's several of them that it sends. I apologize, I'm not finding off the top of my head. This is funny. I've actually got Google's AI built into my search engine now. Services. All right, let's see here. All right, here they are. Bingo. All right. So time on 37, TACUS, it is TFTP. I'm sorry, it does 69. Why would that be important? Why is that important in the Cisco world? Who said TFTP? Was that you, Corey?
It was me, Nicholas.
Yeah.
Nicholas.
Yeah.
Okay.
I made
Nicholas.
it.
Yeah, why is it needed, Nicholas? Why do you need TFTP on for a Cisco router sometimes, or even a?
Probably for our phones when they boot for the first time.
That is one. Our phones. Also, remember, you can set a router and a switch to grab their config off a TFTP server.
Very true.
So you can do that. Now, it's not something we do often, but it can happen. So these are all the different services that are used. You notice that, again, DHCP port 6768, which is the same as these BootP, which we all know DHCP is an extension of BootP. But you'll see time, so NTP on 37, DNS, UDP on 53, TACUS on 49. All of those are also sent by the IP helper address. So just be careful with it. It can send things that you are not expecting. Here's some of the other message types we see here. Declines, acknowledgements, NACs, release, inform. I'm trying to remember on a Cisco DHCP server. I know on Windows DHCP servers, clients try to renew their lease at 1/2 the time interval. And then if that doesn't work at like 66% of the time interval, if that doesn't work, then it's like 1/3 of 1/3 of 1/3, and until finally you just drop your IP address. Now here's setting a router as a DHCP server. In other words, not server, DHCP client, which is, I'm actually going to do some stuff, some kind of fun stuff on the National Internet Working Contest, playing with DHCP stuff. But IP address DHCP would have this address grab its IP address via DHCP instead of being statically assigned. Here's an example of a DHCP server configuration on a router. Now, folks, I know real world, we're going to use a Windows box more likely for our DHCP scopes, just because they're easier to manage, in my opinion. But don't forget, you must exclude the addresses first and then the pools. By the way, you want a good troubleshooting thing? Exclude all the addresses in the pool. I've actually seen students do that in the lab. They accidentally exclude everything and it will not give out an IP address, and they couldn't figure out why. And I had to sit down and say, well, look, you just excluded everything in the entire range, so nothing can be given out. All right. So not porting broadcast. So for troubleshooting, look for relay agents, look for incorrect DNS and default routers. Your default gateway is wrong inside of the scope itself, or they call them pools. I like to call them scopes, 6.5 dozen. All right. Show IP DHCP conflict. This is a command that we probably have not seen anywhere but here, and it will actually try to find the duplicate address and will say where there's a duplicate. So this would say, hey, there's a duplicate on 172.16.1.3. You need to go find out where that's at. Once you resolve the issue, you can do this clear IP DHCP conflict star to clear it out and then run it again, and it will try to attempt to see if there are any other conflicts on the network. Debug IP DHCP server events will let you see all the events. Be careful with debugging these events because in a network with a large amount of traffic, this could cause a pretty overwhelming amount of information to hit your router. So just be careful with that. Now, IPv6 addressing, don't forget, it's 128 bits, hexadecimal. First 64 bits are the prefix. Last 64 bits are the host ID. The host ID used to be generated by EUI64. Now it's generated randomly. Or you can assign it. You can always assign the host portion. You don't have to have it generated randomly. There's EUI64. Remember, if you see anything on the exam and in the middle of the address is FFFE, more than likely, and I mean the middle of the interface ID address, if it has FFFE in it, more than likely that's an EUI64 generated address. Not always, but about 9 times out of 10, maybe even 9.95 times out of 10, it is an EUI64. Can you remember why, if you were in any of my classes, why I told you they went away from EUI64? Why don't they use that anymore?
No, I don't remember.
Anybody remember? Anybody know? Anybody think of a reason why it'd be bad for you to be able to be tracked by your MAC address?
I thought that they obfuscated it now.
Yeah, they made it, they obfuscated because here's the biggest reason.
Security.
What if you live in a country that is trying to track down people who are dissidents or are doing things that the government doesn't want? You could very easily be tracked with your MAC address. All right. Yeah, you're right, Charlene. I was an idiot. I saw that on the slide that the whole thing was on the next slide like a doofus. Sometimes I have been hit by a truck, so that's my excuse, and I'm sticking with it. I've literally been hit by a truck, so when I do stupid things, that's my excuse. And I even looked through all these. All right. Now, IPv6, we have 3 main ways we hand out or we get IP addresses. One is through pure SLAC or auto config. Stateless address auto configuration. That's where the A flag is set, and it's the only flag that's on. We also have stateful and stateless DHCP. Stateless DHCP says go to the DHCP server for some information after you get your main prefix from the router using SLAC. So you may go get your DNS, you may go get other options that are available on a stateless DHCP server. And then we also have stateful, which is 100% go, hey, I'm not going to give you an IP address, IPv6 address, go talk to the DHCP server. It's very easy to enable SLAC. By the way, you can just, if you want it on a router, so this is kind of like making it a DHCP version 4 address or interface. You just do IPv6 address auto config on an interface. You do need to have IPv6 unicast routing enabled. So do that. And with SLAC, when the device boots up, it sends out a router advertisement, actually a router solicitation. It gets a router advertisement that has the prefix, and using that prefix, it builds itself an address. Okay, so it will get the prefix, it'll get the first 64 bits of the information, and then using a randomly generated interface ID, it will give itself that. Okay, you'll notice too that unless you set it, it will randomly generate itself a link local address. Okay. So IPv6 unicast routing must be enabled for a router to respond with a router advertisement. That's one of the biggest issues I see, is that people never discover router advertisements are suppressed. Okay, you got to make sure they're not suppressed, because you want to be able to actually show you want unicast routing on. Now, here's stateful DHCP. You got to create a pool, and you tell it IP DHCP server pool DHCP, and then you also need to change the interface to have the config flag set differently. Now, this IPv6 ND other config flag, this is stateless auto config, all right, or stateless DHCP. So you're still having Slack. Slack still works. A is still left on. You have not turned off Slack, but you've told it, go look for a DHCP server, and then you will have to put the pool in here too, okay? Now that's the other flag, if you remember it. We then have our manage flag. Let's go down here and I'll show you the manage. No, I only show the manage flag. But the other one is IPv6 ND manage config flag. And then with manage, it has to go to the DHCP server for everything. For the address, for the options, everything. The router cannot, using the router advertisement, send out the prefix to the clients. Okay. So, 4-step process for DHCP. There's a solicit using the multicast address FF02::1:2, which is the all DHCP servers. It's so funny because we say there are no broadcasts in IPv6, but there are things that function very similar to a broadcast. Now, having said that, only DHCP v6 servers listed on this FF02::1:2, but that multicast goes out, and every DHCP server that sees it then sends out an a unicast advertise offering address to the client. Now, how does it do that? Tries to use linked local addresses. Client sends a request, and then finally you get the reply. So you can see the real difference here from DORA, discover offer request acknowledgement, is solicit advertise request reply. So SAR. Solicit advertise request reply, SAR. Now there are a lot more other messages here. You can see the confirm, renew, rebind, reply. So there are still a good amount of messages from DHCP. I don't think you're gonna have to know all these message types in order to pass the CCNP ENARSI, but it's just here so you can see that how similar it is to DHCP version 4. There is a relay agent, just like there is inside of IPv4. So you can put in here, you put IPv6 DHCP relay destination and put in the IP address of the DHCP v6 server. All right. I'm not going to spend a lot of time on this. Any questions on, everybody remembers process switching, Ceph, and fast forward, right? Those 3 different items.
It's slowly coming back.
Yeah, there's just remember what Ceph is. Ceph is, which is what almost all routers now use. Ceph actually goes in and builds a table of all the possible destinations, all the egress interfaces that are available. Pre-builds that table so that it does, when a packet comes in, you don't have to shunt it up to the CPU to do a lookup. Process switching shunts every single packet up to the CPU for a lookup, and that's very inefficient. And then fast switching shunts the first one up, makes a decision, puts that in a table, and then every other decision on a packet going to the same destination can use what's in the table for that flow. Now, if it's a different host, it may have to do another lookup again because it's not part of the same flow. All right. But show IP ARP, they're running you through some commands here. Show IP Ceph. This will let you actually see Ceph, the exact route. You can actually see what route is being used. So if you're getting some weird routing going on, you can actually look and see inside and see what Ceph is trying to do. Now this is something we talked a lot about, sources of routing information. Don't forget the difference between a metric and administrative distance. Metric is how you decide the best route within a protocol. So if it's OSPF, the metric is cost. lowest cost is going to be the best route. If it's EIGRP, it's a bandwidth plus the sum of the delays. Okay. The metric is within a protocol. Administrative distance is when you've got routes to the same network from two different protocols, and you need to determine which one of those two are the most trustworthy. That is AD. I would know EIGRP is 90, OSPF is 110. I would know that RIP's 120. It's kind of useless now. BGP internal is 200, external is 20. But most of the ones we deal with are connected, static, EIGRP, OSPF. I'm not going to spend any time on static routes. I think everybody's feels pretty good about static routes. Any questions on static routes? They got your trouble tickets in here. You can look at how pings fail, what the problem is. One of the things I always try to do, if you're trying to ping all the way through a router out to an exit interface, I would ping to make sure I can get to the internal interface first, make sure I can ping the other PCs locally to see if it's a problem with just that one PC or is it a problem with the network itself. If it's a NAT enabled router and I can ping everything inside but can't ping outside, I'll do a show IP NAT trans to see if there's a translation going on. It could be a problem with the NAT ACL. Could be a problem with routing. Could be a routing issue. Do a show IP route. Can I even get to that network? Can I ping it from the R1? Can I ping it from the actual router itself to see if I can get there? This was a very simple one, just the wrong internal default gateway. So I'm not going to go. The rest of these you can read for yourself. So any questions on this first chapter, which is pretty simple? All right, let's jump to chapter 2. Chapter 2 is getting into a topic that if you were not in my Encore class, you're probably struggling a little bit with, because we did EIGRP in that Encore class. Actually everything that I saw inside of here was covered in the Encore class already. The big thing about EIGRP in the CCNP versus EIGRP previously, when it was in the CCNA, there are two modes now. There's a classic mode of EIGRP where you basically do router EIGRP autonomous system number, then you put in the configs for IPv4 underneath that, and then with classic mode you put IPv6 configurations under the interfaces. The new mode, which is named mode, allows you to put everything into address families underneath a main config for EIGRP. So it's more common. EIGRP is a distance vector routing protocol. All right. It is not a link state protocol. It is, many times we've seen it called an advanced distance vector routing protocol. Years and years ago, if you've been in this business for a while, yep, Eric, SIP does equal ASIC, exactly. But many years ago, what do they used to call EIGRP? Instead of a distance vector routing protocol, what do they call it?
Hybrid.
Hybrid. Yep, they called it a hybrid protocol. It's not really a hybrid. This thing's still distance vector, folks, but it's got some advanced features like triggered updates, neighbor table, topology table, route table. It's got some very advanced features that allow it to be a little quicker. It is also no longer just a Cisco proprietary protocol. It has an open standard out there, but it is considered by many to still be basically a Cisco protocol. So autonomous systems, remember, an AS is a group of routers under the control of a single organization, typically running the same internal gateway protocol. All of our internal gateway protocols like ISIS, OSPF, EIGRP, RIP, IGRP, they run within an autonomous system. When we putting autonomous systems together, so like this, if I was running this, between these two autonomous systems, if we had we're running a routing protocol, it would probably be BGP, because BGP is the only external gateway protocol. Now, the good thing about EIGRP is it's actually written to have what are called protocol dependent modules. It has its own RTP, or reliable transport protocol, for the transport layer. EIGRP supports both IPv6 and IPv4. It's got a concept it uses what's called the dual algorithm or diffusing update algorithm. It's got a funky metric we'll talk about in a few minutes, but the metric comes down to bandwidth plus the sum of the delays. And it's actually the slowest bandwidth plus the sum of the delays times 256 will get you your metric. But it has a concept of what's called a successor route and a feasible successor route. A successor route is the best route to a destination. A feasible successor is a route that meets the feasibility condition. Now, we'll talk about the feasibility condition, but it basically comes down to the reported distance of a neighbor is less than the feasible distance. It'll make a lot of sense when we actually show you a picture of it. So just hold on, I'll show you a picture. The other thing you need to think about in EIGRP that is a little bit weird is if a route is passive, that's good. That means the dual algorithm is not running. So a route that is passive, when you look at the topology table, good. If it's active, that's bad. That means it's actively running the dual algorithm to try to find a better path. So again, here's our different items. Successor route's the best route. Successor is the next first hop router in the successor route. Feasible distance is the metric for the lowest metric path. The reported distance is the distance reported by a router to reach a prefix. So it would be for R3, it would be what it reports to R2, its distance to 10444 is. So it would be 256 plus 2816 would be the reported distance of R3 to the 10440 network. Okay. Feasibility condition, to be a backup route and actually be stored in the topology table, it must have the policy of the received distance must be less, and it must be less than the feasible distance calculated. That guarantees a loop-free path. Now let's think about this for just a second. Okay. Let's look at right here. Let's look at this table. And I'm gonna make it a little bit bigger if I can. Yep. All right. So let's look at this topology table and figure out why this makes sense. Okay. So our successor route, the best route available to 10440, is the route that goes across right here from R1 to R3 to R4. Okay, that's the best route because it's 256, 256, 2816. So we look down here and we see that it has a feasible distance of 3328. Best route. Okay. Now you'll notice that there's another route up here, and that route is from R4, from R1 to R4. It's not the best route, but could it be a route that does not have a loop in it? Well, R4 is reporting that its reported distance is 2816. Now that's a little weird because it's actually using the destination network as part of the metric, but that is how that works in EIGRP. So R4 says my reported distance is 2816. Now let's think about this for a second. If the absolute best route to the destination has a value of 3328, and a neighbor reports that it can get to that same network with a reported distance of 2816, it cannot come back through the router it is reporting that to. Okay, now it took me a little while to get my head wrapped around this, but it makes perfect sense to me now. Now think about this. The path from R1 to R4 is, let me do something real quick. I'm gonna pull up my, I gotta find my pen. I'm gonna pull up my whiteboard, folks. I'm gonna do a little drawing for you. Don't see whiteboard going here. Oops. Come on, man. Whiteboard's fighting me a little bit, y'all. Give me just a second. Okay. So let's look. We got 3328 and 2816. All right. So let's move this over. So looking at this, we know that this route right here from R1 to R3 to R4 is 3328, I think it was. Let me go back. I'll make sure I get it right. 3328. Okay. So we know for a fact that the best route, the absolute best route that takes this path right here, it goes right down through here to the 1044 network, is 3328. Okay. Now, R4 reports back to R1 that its reported distance to get to this network, okay, so it's going to report its RD is 2816. Okay, so the feasibility condition says the reported distance must be less than the feasible distance. Now, see the reported distance, 2816. Is that less than 3328? Yes.
Yes.
Okay. Therefore, it meets that condition and it can be placed in the topology table as a feasible successor. Now, the reason this cannot be a loop is because this number being less than the feasible distance, there's no possible way that whatever route R4 has goes back through R1, because R1's best path is 3328. And so if R4 was coming to R1 to get to the 1044 network, it would be higher than 3328. It would have to be, because R1 would add its value of 3328 to whatever route R4 was using to get to the 1044 network. So that's how it guarantees a loop-free path. The reported distance of R4 is less than the best distance. So R1 knows it doesn't come to me to get there. Now, I don't know how it gets there really, but well, it does actually, because now it's going to learn about it. But it says it doesn't come back through me. So this is an alternate path. It's not my best path, okay? Because, you know, if you add this 2560 to 2816, that's higher than 3328. So it's not my best path, but it is a feasible successor, or a feasible successor route that can go into the topology table. That if this successor route fails, EIGRP doesn't have to run the dual algorithm. It doesn't have to go active on this route at all. It just takes the feasible successor route, puts it in the route table immediately. That's one of the reasons EIGRP can be so fast, folks. EIGRP, with its concept of a feasible successor, has backup routes inside of the topology table that allow it to very quickly recover. Now, if there is no feasible successor in the topology table, that doesn't mean there's not a backup route. It just means it didn't meet the feasibility condition. And what will happen then is EIGRP has to go active, has to go out and actually send query messages about the particular network that it's trying to find out about, and all the routers have to respond to it. That feasibility condition is a massively important concept with EIGRP. Do you understand it? Are you okay with it? Once I got my head around the fact that, oh, yeah, that makes sense. If its reported distance is less than the best route, there's absolutely no way it's going back through the router that has the best route. Otherwise, it'd be higher than that 3328. Okay. Now, by the way, the topology table will only show, you'll notice, if we go back up here, how many routes does R1 really have to R4? It's got this feasible successor route. It's got the successor route. It's got a route that goes around the outside. It's got a route that goes R3 to R2 to R4. So there's other routes there. They don't show in the topology table unless you do the all links keyword. Okay. So if you do show IP EIGRP topology all links, it would show all of the links, the successors, feasible successors, and those that do not meet the feasibility condition. Okay. Now, EIGRP does not rely on periodic advertisements of all the prefixes. It exchanges things with triggered updates. Here are our 5 packet types that are used with EIGRP, and you'll notice that it uses on IPv4 224.0.0.10 as the multicast address. It uses FF02::A for IPv6. I believe that's correct. Pretty sure I got that right. Okay. But here they are. We got a hello packet that's used for discovering neighbors and detecting neighbors, request to get specific information about a route, an update, transmit routing and reachability, a query to search for a path for convergence, and then a reply is sent in response to a query packet. So request is for specific information. A query is about an actual path. Neighbor relationship. You'll notice that in order to form a neighbor relationship, that'd be part of the same AS. They must have the same K values in their metric, and they must be on the same primary subnet. Last but not least, you do have authentication enabled on one side. Authentication does have to be enabled on the other side. The authentication does have to match on both sides. So here's our 2-mode, classic versus named. Time we got. So here we see the old mode, router EIGRP AS number, and then we use our network commands. That's the old classic configuration mode. Named mode uses our address families. And we also have an interface sub mode where we can do overall default items for interfaces, and also individual items for interfaces, like making them passive, making them stub, etc. And then even more topology sub mode. So in the EIGRP name mode, there's 3 basic subsections: the address family, which can be IPv4, IPv6, which lets you again set those global variables, and then the interface variables, and then the topology variables. You really just have to play with these, especially in name mode. You have to do configs and play with them in order to get comfortable with what all is in what part of the name configuration. Here's classic mode, router EIGRP1, autonomous system number. Now, I will tell you something. We do call it an autonomous system number, but honestly, it's not really an autonomous system number. It's more like a work group name than an autonomous system number, because the ASN, the autonomous system number here, does not match the IETF autonomous system number like it does with BGP. So to call it an autonomous system number is a little bit of a misnomer, but just be aware that is what they call it. So here's a sample topology with classic configuration. We go in router EIGRP. We then advertise all the networks that are attached, directly connected. Below, you'll see a configuration using EIGRP name mode. You'll notice they also did something different on the name mode. They just said advertise everything. So they said router EIGRP name. They put address family IPv4 unicast, autonomous system 100, and then network quad 0, quad 255, and that says advertise every single network on my router. So anything that's up and configured on an interface will get advertised. You can do the same thing with OSPF as far as quad 0 is quad 255. Show IP EIGRP interfaces shows your interface information. Show IP EIGRP interfaces detail will show you the hello interval, the hold time, which by default is 515 on Ethernet interfaces, and we can change that. Neighbor adjacency, show IP EIGRP neighbors. This should not be anything new to you. And then install route, show IP route EIGRP, shows our EIGRP routes. Remember, D means it's learned by EIGRP. They use that because it uses dual. Dual is the algorithm. So instead of putting an E there, they use D for EIGRP. DEX would mean an external route that was injected into EIGRP, either being a default route that's been injected into EIGRP or some other route that was brought in through some method, either redistribution or otherwise. Now, we can also do router ID. You can actually set that by default. If not, it's the highest IP address on any loopback. If there's not any on the loopback, it's the highest on the physical interfaces when you actually turn it on. Most of the time in the real world, we configure an actual router ID for EIGRP. Passive interfaces. These are interfaces that will not send out EIGRP hello packets and use this on interfaces that are not connected to other routers. You also can do passive interface default, which makes all interfaces passive, and then do no passive on certain interfaces. So if you know 10 of the interfaces are passive and only one is supposed to be non-passive, it's better to do it all default and do it the other way. Okay. Now under named mode, you'll notice a little bit different. You put it in name mode, you go in the address family for IPv4, then you go in the address family interface. So you go in the interface config mode for G01 or G02, make it passive. You also can do AF interface default, make all interfaces passive, and then back down, exit that one, and then go into the individual interface and put no passive interface. Notice how the difference between these is with classic, your configuration is spread out throughout your config. With named, everything is in that named configuration portion of the configuration. So we're really going to named. Everybody's going to name now. EIGRP can have authentication, which means two routers, before they will exchange EIGRP information with one another, have to actually authenticate using a shared key. You create a keychain, you just assign the shared secret key, whatever it happens to be, and then enable authentication on an interface. So keychain EIGRP, key 2, key string Cisco, that says that the password is Cisco. Then you go in the interface, IP authentication mode, EIGRP MD5, and then you tell it what key to use, which is referencing this keychain up here. Bottom is showing you this same thing in named configuration mode. So you go into a keychain, do your key string, then you go into your name mode, you do address family, IPv4, unicast, autonomous system, AF interface default, and then do authentication mode MD5, and then set the keychain. Now that sets that keychain for all interfaces that are going to be part of EIGRP. So notice how much easier this is, the named versus the classic, because with classic, you got to go to every single interface that's going to do authentication and put it on those interfaces. You don't have to do that with named. So show keychain will show you your keychain. Show IP EIGRP details will show you that authentication is set. Interface detail will tell you whether or not MD5 is on and what the keychain is. So if you're troubleshooting EIGRP and authentication is turned on, one of the first things I would check is make sure the keychains match. Now, folks, we're getting toward the end of the hour, but I'm still going to go real quickly over these path metric calculations. Metric is the way to determine the best path within a protocol, and EIGRP has what looks like a very complicated metric, but it's not. There are 5 K values in classic EIGRP. There's 6 in named. The 6th one is not really, honestly, the only 2 used are K1 and K3, which is bandwidth, lowest bandwidth, plus the sum of all the delays in microseconds, in tens of microseconds. Okay. So what you end up with is bandwidth, lowest bandwidth, plus some of the delays times 256. So this is really what falls out. It comes down to metric equals 256 times 10 to the 7th divided by the minimum bandwidth in kilobits per second, plus the total delay in microseconds divided by 10. And that's how it gets its metric. Okay. So you can see the update packet includes path attributes associated with each prefix. So you get hop count, cumulative delay, minimum bandlink speed, and reported distance. All of those are part of what's being sent with each update packet. So that's how it can configure the metric, is by looking at that information that comes along with the updates. You'll notice that default metrics, classic metrics you'll see here. These are the default metric for serial is 40 million, all the way down to 10 gigabit at 512, if it is a 10 gigabit link. You also can look at the gigabit. So scale bandwidth is 10 million divided by 1000, which is a gigabit interface. Scale delay is 10 divided by 10, which is 1. So you'd end up with 10 plus 1 times 256, which is 2816. That's how they get that 2816 for a gigabit link, and how they get 256 for 10 gig and so on and so forth. Now, because of the need to accommodate faster links, they actually scaled everything by 256. It's called a wide metric, and it's really what is used for name mode. The problem is it made it so wide that it wouldn't actually, you couldn't actually put it into the routing table. So they ended up having to divide it by 128. But either way, the metrics are backwards compatible by either multiplying by 256 or dividing by 256. Almost everything now is using the new setup, so you don't have to worry about that. Now you can change the K values, but remember, in order to form a neighbor relationship, the two devices have to have the same K values. If they don't, they will not form a neighbor relationship. So if you do a show IP protocols command, by the way, I would know that because I've seen 3 questions now and stuff I'm studying about how do you find these set K values on a device. Show IP protocols. Put that in your notes. In fact, I'm gonna make yet another note for myself so that I know. It's funny because everybody says nobody uses OneNote. I use OneNote. Okay. I studied for my certification exams. So I'm gonna dump this in my OneNotes so that I know. Okay. Now, last but not least, we're gonna stop after this. Load balancing by default. EIGRP will load balance across equal cost paths. It also has the ability, by default, the max path I think is 6. But it also has the ability, if you want, to support unequal cost load balancing. And it does that with a command called the variance command. And that's it for chapter 2. Now, folks, I'm going to go ahead and stop here. I will go over chapter 3, 4, and 5 next week. Are there any questions on the labs you've been doing inside of NetLabs? 3, 6. This is great, folks. To have 13 people in here. That's excellent.
I have a question. NetLabs, how do I get the account for the NetLabs?
How do you get what?
The access to NetLabs, the account.
You've already got an account. Let me go in here and grab your, should be the same account you've used in the past. And that was, yeah, you've never logged in. You've never logged in before, have you? Okay.
No. I have used the NetLabs before, but with even the Stanley, but that was a long time ago.
Okay, let me send this to you. Okay, there's your username. And I'm resetting your password to Cisco123.
Okay.
And the server is netlabs.stanley.edu. Boo. It's your password is Cisco123. So the netlabs.stanley.edu is our server.
Okay, thank
And
you.
if you will, please go back. I know you joined the class late. Go back and watch the video from our very first class meeting last week, because it walks through everything that you need to do in terms of what's required for this class. I need you to go read the syllabus for me, make sure you understand all the stuff that's needed there. So
Yeah, thank you. I already went through the syllabus. I will go over the video.
yeah, watch the video, because that's the main way I give out information. So
Thank you.
but that's please make sure that you have go ahead and check your access right now, make sure you can get in.
Yeah, NetLabs.
Yeah, on NetLabs. Janaka, just so I make sure you're in.
Yeah, I was
Um,
here. I
No
was
problem,
here.
Charlene. That's not a problem. If you have questions, just let me know. And this so far it's been a fun class. I've enjoyed the sections I've looked at so far. I think it's gonna be an interesting exam too. I'm looking forward to seeing how everybody does. I'm gonna stop the recording, everybody.